So, our first topic of discussion today is why learn traditional industrial technologies in the first place? Why does it matter? Well, it really comes down to technology innovation. And according to Innovation, Management Policy and Practice by D'Souza and others in 2009, there are 6 innovation stages. And I want to focus on a couple of them and the important role they play for us. It begins with idea generation and mobilization, advocacy, and then screening, choosing the best ideas. And then finally, experimentation, and they call it commercialization. I'm kind of rephrasing that to implementation. So experimentation is the ability to test the innovation in order to see how it's going to impact the environment and in order to determine if it's going to bring us benefits. And then the commercialization, of course, in their model, thinking about innovating and creating a new product. But in our model, we're thinking about innovating and implementing a new technology within an environment. And so we'll take that as implementation, actually rolling out the solution. Well, the key area where we come in then is experimentation and implementation. Sure, we might be involved in idea generation and mobilization. We might need to advocate for the innovation. We might even screen out different possibilities and pick the best solution. But as a technical individual implementing the actual IoT solution, we're going to get most heavily involved when it comes time to really begin the project and actually be involved in experimenting on a small scale and then implementing on a full scale. So here's the thing. It's challenging to innovate the unknown. So how do you innovate something if you don't understand the thing that you're innovating? And that's why it's important to know what is already being used in industrial automation solutions so that we can best understand how the newer IoT solutions that are coming along can also provide a benefit. And there is a real stark difference between traditional industrial automation and the newer IoT automation that is being evaluated in industrial environments and other types of manufacturing and processing implementations. Integration is often the first step of actual innovation actions. In other words, we don't go in and just replace, we innovate. Radical innovation is rarely the thing that we use in industrial systems because it's already there, right? There's a process that's there that's working, and we don't go in with a forklift and just rip out all of the industrial automation they have and replace it with modern IoT solutions. More often than not, there's integration over time, so that we can get the benefits or advantages of IoT technologies. These are automation technologies that may have internet access, for example, and we get the benefits that they bring. So we add them where they can provide a benefit, but it doesn't mean that we wipe out all of the stuff that's already working. We may integrate IoT for monitoring of existing automation systems for some type of management and reporting. We may implement IoT in new automation systems that are going forward, and we may still implement new traditional industrial automation alongside of it as we go forward. So it's important to understand that incremental innovation is typically what we see used in these industrial environments because they need to continue operations. So a forklift replacement doesn't usually give the results that are needed. So successful innovation is really driven by proof of benefit. That is to say, in the technology area, if we're going to encourage and successfully achieve motivating people to implement a new technology, we have to prove it beneficial. And in the book called Diffusion of Innovations by E.M. Rogers in 2003, they actually defined 5 key things that successful diffusion of innovations include. So diffusion, as you know, is spreading about, right? So if the innovation is going to spread, if the innovation is going to be successful at getting into an environment, then we're going to have to look at these 5 factors. One is relative advantage. How much better is it than what we already have? Why would I use an IoT solution if the existing PLCs or RTUs or what have you, and we'll talk about what all those are if you're not familiar, if they're already working and getting the job done, and it's not any better to go with IoT, it's a tough sell, right? So we've got to ask, what's the relative advantage of it? What is the compatibility? So how does it work with existing needs? Is it not so much compatible with the existing systems, but is it compatible with the need? So can it achieve the end result? So we're now putting two things together. Can it achieve what we need to achieve? And can it do it better than what we're already doing? And then there comes the factor of complexity. How difficult is it to implement and utilize? If this thing is extremely complex, does it mean we need new professionals on staff to manage it in addition to the ones we already have? Can the current staff be trained to management? So in the world of industrial environments, we have what are called OT professionals, operations technology, instead of IT professionals, right? So they deal with the PLCs, the RTUs, the DCS, the SCADA systems, all of these existing automation systems. They deal with that. They know how to work with it. Are those OT people going to be trained on IoT, or is someone else going to be responsible for it? And the complexity can drive that in some cases. And then they used the term trialability. And what that means is, can I implement this IoT solution on a small scale to prove the theoretical benefit that I've already established? So maybe I've statistically proven that it can be beneficial, but can I do a small scale implementation and actually let management executives, even OT professionals that are using the other systems, see the benefit that it brings? And then there's this factor of observability. Are the benefits obvious? I'm sure you've been involved in technology innovation projects in the past. I know I have, where you implement this sometimes multi-$100,000 project or even multi-million-dollar project, only to have it implemented and in place, and people really take the same amount of time to get the same job done that they did before. So there's no time benefit. Quality hasn't really improved. Nothing has changed that's obvious after implementing this, other than we're doing the same thing that company X is doing. And so we're doing the right thing. So we've got to be able to see obvious benefits in this small scale trialability, the trial that we do, in order to really have that motivation to go forward. So these are key things. And I know this is kind of the soft side of technology, and we don't like to think about these things as much. We like to get in there and play with the knobs and switches, but these are important things to consider, particularly as IoT is making inroads into industrial, oil and gas, supply chain management, and all of these other areas.